Hi guys, my name is Ram, and from today we'll be learning about how to deploy a website with Git, Jenkins, and Kubernetes. Now, when I say website, I'm being a little bit generous. I don't mean an actual website. So I want to make this clear. We'll basically be doing a static website deployment with Git, Jenkins, and Kubernetes in today's session. So that's going to be our goal basically today. All right. Now, before we do begin the session, I want to know from you guys whether you guys can hear me properly and whether you guys can see the screen properly. So that's our general, a drill that we do. We want to make sure that, you can see us, and we want to make sure that you can hear us also. And I have the chat open on the side, so I'll be looking at what you guys are saying. And I don't think we have a lot of people watching today. I think that may be because of a lot of reasons, especially because this is a very unique topic, but that's not a problem. I always love teaching you guys, and it's always fun and interactive talking to you guys while doing the thing. So I'm chatting as well as talking to you guys. Now, one thing I want to make sure that you guys know about is great learning. So, Great Learning Academy is something you guys should definitely check out if you want to, learn more about a specific domain. So, let's say you want to try out more full stack development. So, we have a course catering to just that. See, Introduction to Full Stack Development. You should go ahead and check this course out. This is really good course, especially if you're into DevOps or such technology. That's a really awesome course that you guys can check out. Now, again, the thing about Great Learning Academy is that it's a free website. You don't have to pay anything over here. This is a completely free course, obviously. So you'll just be, going through all of the content, all of it, and you don't have to pay a penny or a paisa, if you're talking in rupees terms. And again, once you are done with it, you get a certificate at the end of the session. Once you get the certificate, you can always tell people that you have certain, credibility behind what kind of knowledge you have. So it's always good to have certificates for certain topics. So please go ahead and check out Great Learning Academy. It is a free venture that we started to help people out because of the COVID situation, and a lot of people have lost their jobs and a lot of people can't find jobs. So this is something for you guys from us, free. You don't have to worry about paying anything. All right. So that's about Great Learning Academy. I don't see a lot of comments coming on the chat, so I'm assuming that you guys can't hear me. Please let me know in the chat if you guys can see and hear me properly, because then there's no point otherwise to continue, right? I want some input from you guys. Go ahead. Tell me what you guys think. What do you guys know? Also, tell me one more thing. How many of you know about this particular deployment? Like, how many of you know about Git, Jenkins? Is my chat not working? Let me just open up my chat. I feel like my chat is not working because I'm not seeing any messages from you guys. Okay, okay, yes. So it was definitely the chat not working. You guys are giving me an audible yes or no. Okay. All right. So Nabin is saying, sir, please make a Django web development. Okay, sure. We'll work on that. That's a good suggestion, Nabin. We'll definitely look at it. Ashi Nivasan is saying, I don't have exposure to this. This would be useful session. Now that's a really good mentality you're going with. Okay. So Gaurav is saying never use. Aisha is saying I've done IAN or the LAN on Quick Labs about it. So you know something about it. Ramamurthy is saying I do not know nothing about it. So please make the session again. I get it. Please do not spam the chat. I will recommend your suggestions to the relevant team. All right. So I see a lot of people don't have an idea about it. So here's what. Let me get you guys a brief description about each of these things. So I came prepared. I knew that each of you would be, at least if you didn't know about these topics, or if you knew about these topics, it would be a revision for you. So let's go ahead and get into these things. Now, before we get into these things, I just want to give you guys an overview of what we will be doing. Now, so this is what we'll be doing today, guys. We'll be basically going ahead and launching our static website. So I do not have an HTML file over here, but here's what I can do. I can go ahead and write an HTML code, a very simple code, no need to write anything fancy. My website title, and let me write a paragraph tag. Hey guys, I love ice cream. All right, so that's our paragraph tag. So this is basically going to be a static website. Now basically what we are trying to do over here is we are trying to we'll be trying to deploy this. So if we do it normally, let me go ahead and save this. Save as, right, as hello.html. You guys can see it automatically lit up. So if I refresh over here, yeah, so I have my hello dot, yeah, so this is what we should get. Hello guys, hey guys, I love ice cream. All right, so let's come back over here. Right, so what we're going to be doing is basically we're going to be using Git as a repository to store all of our code. We'll be using Jenkins to automate the whole process, and we'll be using Kubernetes to deploy anything we want. So what is the difference between all these three things? Let's go ahead and see them one by one. Now Git. So a lot of you may already know about Git. Git is a version control system, right? So here we'll basically be trying to use Git to store our code and to organize our code. So if I come to my browser over here and head to my GitHub account, so it'll give you guys a better idea. So over here I can create repositories and I can store my code, right? Okay, so I can create a new repository and store code over here. And that is basically what Git does. It allows you to basically version your code, right? So let's say that you have two developers and they want to, develop particular functions for their company. So what they will do is they will make use of Git to basically, write. First, they'll write their code, and then they'll use Git to basically commit the changes that they made or anything new that they have added and push it to a GitHub repository. So these guys might share a singular repository, and from GitHub it can go for deployment, and that's what we will try to do. Right, so we will send it to Jenkins, and from Jenkins we'll try to send it to Kubernetes. We'll basically be using Kubernetes and Jenkins in the same server. So I'll tell you guys how it goes on. Okay, so Git is that. So I hope you guys know what Git is. All right, so this is like basically the life cycle. If you guys remember, I've taught this many times in my previous sessions also. We have assigning a working directory, initializing local directory, staging, and then committing, and then storing on GitHub. All right, so now let's talk about why do we need Kubernetes. So how many of you guys know what Kubernetes is? Because I know a lot of you may know about Git, but I am not so certain that you guys might know about Kubernetes. So let me know in the chat what is, if you know what Kubernetes is. Now, I know a lot of you have clicked on this session to know more about Kubernetes and how you can deploy on that. So go ahead and tell me if you know about it. And if you don't know about it, tell me any related topic that you might know about, Docker or something. Because I want to know what you guys know, so I can explain, fill up the gaps basically. So while you guys are giving me the answer, I want to start talking about why do we need Kubernetes. So in a normal deployment, when we talk about software development, we need to deploy our software. What is deploying a software? So let's first look at the pipeline in which we develop a software, right? So a software developer will basically write the code that is required to run the software. Now remember, code is not exactly the same as software. Code is whatever syntax, whatever stanzas, statements that you write. Basically, all of this is your code, but it is not automatically a software, right? So it needs some other tools, some dependencies to become the software it is. Right, so with HTML, we might need other stack of technologies like the backend, and we might need the middleware and the database and all of those things, right? So all of those things together make our software. So what the developer does is he takes the code, he takes all the dependencies, and he starts building it into a software. Once he builds it into a single executable unit, he makes a software. Now this software gets tested by a tester. The tester tests it rigorously and checks for any mistakes if there are any. Now once he approves it, then this particular software can go ahead for deployment. Now the deployment over here is basically you're taking the software that has been tested and you're putting it in an environment or a server from where it can be exposed to the users. So let's say we are talking about YouTube. The YouTube end product is the streaming service that they're providing. So it is on a production server and it is exposed online, so anyone can use it, right? So that is basically your deployment process, where you put it in a particular server where it is exposable to everyone, right? So we'll see that. I'll give you guys an IP that you guys can target and you can see the app that we have deployed. Alright, so this is the standard delivery pipeline. Now there are some issues that can happen over here because we're not using any complex methods. These guys are just transferring the code in either hard drives or sending by mail or messages, whatever. They're very amateurs. They don't have a clear-cut idea of what's happening. So over here you guys can see the developer's environment and the tester's environment. So in developer's environment, you have the operating system that is CentOS, PyTest 5.4.3 for testing things, PyCharm IDE, and he's using Django backend code. He's writing that and he has certain dependencies. Now the tester has a similar environment. The difference here is that he's using an older version of PyTest and he's using a different IDE. Now generally using a different IDE doesn't make a lot of difference, but here we see that the PyTest versions are different. Now this can be a problem. Not this is just for example's sake. I'm not saying that there's a proper differentiation between PyTest 5.4.3 and 5.3.0. Just for you guys to understand. Now both of them have different application versions, so this might cause an compatibility issue because the developer might write the code for one version which may not work for the other version. So the developer and tester must have talked about it, about having a standard environment. Otherwise, it causes problems, compatibility issues. The tester can't use the code that the developer is sending him, so he can't work with the code, right? So to resolve this kind of issue, where you do not have different environments and you have consistent environments, you make use of something called containers. Containers are basically like boxes. So instead of sending the code directly, what the developer does is he sends it in a box. Now this box will contain the code, the dependencies, and he will send it for all the processes. For the building process, where it becomes a software, for the testing process, where it gets tested, and in the production environment. So this is what a container is. And this is what container resolve. They basically help us remove that problem of consistency, right? That was not there previously. It allows us to give consistency. So that's why containers are very important, especially in today's development where you need to automate everything. So that's where Kubernetes comes in. Actually, that's where Docker comes in. So Docker is a tool that allows us to create these containers. So containers basically contain all of your code and libraries, right? Or any dependencies or the environment that you're using. So I haven't mentioned any environment, but you can think of it as here as an environment also. And all of them will be in container. You can use it in any system and server, this container. Now, generally, why do we need containers? One reason that we already stated was to have consistent development environments. Now, the other reason is microservices, right? So what microservices is basically, it's an implementation. When you actually work in the industry, you will not be deploying a single file like you did back in college or back in school, right? What you will do is you will basically divide your software into different parts, like 1, 2, 3, 4, 5, and these 5 are logical parts that they have each function that they've assigned to, and they basically work in conjunction with each other. So instead of just putting those files out there, you can put them inside of containers and you can connect them in a network. So this way it's easy to manage them and easy to scale them. Like if you wanted to add more containers, more replicas over here, then it's easy to do so with microservices. That's why we use containers. So it resolves two problems. Now, Docker is a tool that allows us to create containers. So basically, if you have an application, you can put it in a set of containers and you can deploy it, right? So that's what Docker does. It allows us to create those containers. So when we talk about containers, when we don't generally talk about sending the containers itself, on the different servers, you talk about the images. So images are basically blueprints for these containers. And when you want to send a container, you will instead send the image of that container to the other person's system, and they will basically run the image in which the container will start, from which the container will start, and then they start working on it. All right. Okay. So that is it for Docker. Now with Docker, you can create a lot of different containers, not just one container. To manage them, you use services such as Docker Swarm, or you can even use Kubernetes. So Kubernetes is basically a tool that allows us to manage multiple containers. Let's say that you have 5 containers because you're implementing a five-layer architecture for microservices where you have 5 containers containing 5 functions. To manage all of it, you use either Kubernetes or Docker Swarm. Now today we won't be talking about Docker Swarm, we'll be talking about Kubernetes. So let me go ahead and talk about Kubernetes. So Kubernetes is an open source container orchestration tool that allows us to manage multiple containers in different environments. A pro about Kubernetes is that, sorry. All right, yeah. So a pro about Kubernetes is that it's very secure and it's very robust. When I say robust, I mean that it is very strong. It doesn't break easily. And that is amazing, especially compared to other orchestration tools. So again, I'm telling you guys, Kubernetes is a tool that allows us to manage multiple containers. You guys know what containers are? And when you have multiple containers, how do you manage them? You make use of Kubernetes. Okay? All right, so these are the features of Kubernetes. You have easy updates and rollbacks. That means you can easily update any container. So if you guys remember, I was talking about the 5 containers. If you just want to update one container instead of the whole thing, then you can do that. You can easily update it. Or if you want to roll back a particular feature, you can do that. Storage distribution means that you can share data between these containers without any hassle by using volumes. Secret handling basically means, so Kubernetes is very secure. That means that when you want to connect it with your Jenkins or Git, when you're using private repositories, let's say you're using Docker Hub private repository registry, then you need to have a credential for it. So credentials are basically your secrets. So it handles all the secrets properly. Heals itself basically means that it makes sure that if any particular pod is down or a container is down, it will try to bring it up. So it does that automatically. You don't have to worry about it. Let's say that one of your containers that contains the payment feature, it crashes, right? And you did not know about it. The thing is that Kubernetes will automatically detect that and it will try to put it up again. Like it will try to put it on the production server again. Then there's load balancing, where Kubernetes is very good at dividing the load between different multiple containers. So let's say that you have the payment feature again, and you have two replicas of those payment features. The replica basically means the same container, but the difference is that you use them in certain scenarios. So let's say you have one replica ready. If the first one goes down, that means the first one crashes, you have the second one available. Now sometimes you have a lot of people coming in also, and you want to divide the load between different containers, so you can divide the load between them. So let's say you're using a food delivery app like Swiggy or Zomato, and they see that they have 100 people only first week, but the next week they have 1,000 people. So those 1,000 people, to accommodate them, they basically scale their operations, where they increase the number of servers they have, and the load of the people coming in and requesting, asking for food, gets divided. Easy scaling. Again, I told you guys that you can scale the number. You can increase the number of containers you have for a particular service. So what do Kubernetes do, and how does it do it? So Kubernetes, the basic architecture is this. You have pods, you have a service, and you have an ingress. Now let me explain the pods. Pod is basically a representation of a particular, it's a representation of a particular feature that you're working with. So let's say your company has an application that has 2 features, or let's say there are 3 features. One is payment, one is tracking, and one is a map feature. So each of those pods over here will represent each feature, right? Or what you can say is that, yes, so let's take the previous example itself. So you have 3 features, and 3 features are represented by each of these pods. Now over here, the payment feature is represented by pod 1. The tracking feature is maintained. It's represented by pod 2, and the map feature is represented by pod 3. Now you can see that there are containers within these pods. So pod is a collection of containers. So these containers can contain different things that are required to run that feature. So let's say that your your payment feature requires a gateway, it requires a database, it requires some middleware connections. So all of that you can have in multiple containers that are connected to each other inside a pod. Now you can have replicas of this pod also. So let's say you have pod 1 and then you have pod 1A and pod 1B. So these are the replicas of this pod. So if pod 1 feature goes down for whatever reason, it crashes, you have pod 1A and pod 1B to replace its place. Similarly with pod 2 and pod 3 also. Now generally when you're inside Kubernetes, you can access the pod directly, but when you want to expose it to someone else, right, you use something called a service. So instead of directly exposing the pods, you expose it through a service. So let's say Swiggy is a app, right? Again, it's a food delivery app. So it has multiple features. So what they do is they connect all of them into a service and they expose the service to us. So we can access these pods through those services. Now we're not going in the back end and accessing them, but we're using them over there. So that's what a service is. Now you can have multiple services. If you're a big company, let's say Amazon Web Services. Now, I don't know whether they use Kubernetes or what, but they have a lot of services over here. So you can see compute, robotics, customer enablement, storage. So all of these are services. Within those services, these particular services are there. Like EC2 is one particular service, Lightsail is one service, and each of them will be represented by a pod. Now, compute is going to be our service over here. This is the service, and these are the pods: EC2 pod, Lightsail pod, Lambda pod, and Batch pod. So when you have multiple services, you use an ingress to access them, right? So an ingress acts as a gateway for multiple services, right? So that's your basic Kubernetes architecture. I hope you guys understood that. All right, so before I start with what is Jenkins, I'm pretty sure you guys have some questions. Let me just go through those questions. Also, I asked you a question in the beginning whether you guys know about what Kubernetes is or not. So I see that some of you guys don't know what Kubernetes is. Yashwant is asking, sir, can you please increase the font size? Is it not visible? Don't worry. This PowerPoint presentation will be available as a readable document to you if you click on the link that the moderator sends out in the chat. Okay, you can read it over there. So Srinivasan is saying that they briefly know about container orchestration. So Kishan is saying no idea about Kubernetes or Docker. All right, so guys, again, we have a lot of sessions that you guys can browse through. As in, if I tell you guys, like YouTube, type in great learning and whatever thing you want to learn about. So let's say you want to learn about Git. So I have a particular set of sessions that you guys can follow about Git, or we have a Hindi tutorial. If you're a person who likes Hindi, go ahead and watch that, right? So you can see Git tutorial for beginners in Hindi. I definitely recommend checking this out. It is very comprehensive. It details almost everything you need to know about Git. It will definitely help you get started with Git. Now, if you want to know about Docker, we have a Docker session also. And we are coming up with a Docker course also. So stay tuned for future where we'll be releasing a Docker. Till then, you guys can go ahead and check out our sessions that I've done before in English with Docker. And if you want to learn about Kubernetes, I have gone into depth about Kubernetes also in one of my sessions. So you guys can see I have a Kubernetes session and I have a Jenkins session also. All right. So you guys can go ahead and type with great learning and whatever thing you want to learn. Okay. I have in Hindi and English, whatever you guys prefer. So again, I'll just go and brief what Jenkins is. Jenkins is an automation tool that allows us to automate all the processes. So you guys remember that developers, right? They write the code, the source code manager. This is your Git. So Jenkins. So if you want, you can assign Jenkins to automate all of these processes. Okay. So I'm going fast because the deployment itself will take a lot of time. Let me just explain the pipeline to you. Then we'll go to the installation and all that part. Okay, so developer writes the code. He sends it to a source code manager. This is your Git. And Jenkins detects that a new code has been pushed. So it pulls that code and it starts building it. That means it starts making it into software, the code into software. Once it makes it into a software, it sends it for testing. it sends it to the testing server. Now, once it's on the testing server, the tests will happen. If all the test cases pass, the test coverage is 100%, then there'll be a feedback if something is wrong to the developer. If nothing is wrong, it goes to the staging environment. Now, it'll stay on the staging environment until it has been reviewed by someone or it has been documented. So once it has become a release candidate, it will go into production where it will be available to the users. So this is a basic Jenkins pipeline. All right. So now let us begin the whole thing. So first, what I'm going to do is I'm going to set up my environment. So guys, I'll be using AWS EC2 to launch virtual machines, and I'll be launching two virtual machines so that I have a Kubernetes cluster. Now, Kubernetes cluster is basically a cluster where you have multiple servers that can host containers. I hope that didn't confuse you. Multiple servers, as in you have two servers, and on both of those servers, you can have Docker containers, right? So, generally, when we talk about Kubernetes, you can use a lot of different container services. Docker is one of the container services that is used most popular, which is one of the most popular choices. So, I'm also going to be using Docker to create my containers. To manage those containers, I'll be using Kubernetes. Sultan is asking, bro, how can I live my Angular project? So, Sultan, I'm not an expert on Angular. I have only little knowledge. So, it would be unfair if I started telling you whatever small broken knowledge I have. Here's what I'll recommend. We have an amazing trainer. His name is Faizan. You can go ahead and register for any of his courses. Sorry, live sessions. So let me just show you. You can go to greatlearning.in, and we have courses over here. And once you, not courses, live sessions. So if you click on live sessions, you can look for so data structures in Java. So Faizan is teaching this on November 21st. He can answer all of your questions during that session because he's an expert in that particular domain. All right, so yeah, so here I'm going to be using t2.large. Now I don't recommend you guys to use t2.large also. I mean, you can use if you have the fiscal means, because I'm saying this because this is not a free tier thing. You have to pay a little bit of money. It's not a lot of money, but you still have to pay the money. So please make sure that you know what you're paying for, what you're getting into. Okay, t2.large is not under free tier. I'm going to make these two instances because I want two servers. Okay, so Samarth is saying that actually I'm new to all of this. So can you please guide me to attain knowledge or more? All right. So, Samarth, the first thing I'm going to tell you about is the live session thing, because definitely check them out. You can head to greatlearning.in/academy. Over there, you will find all the live sessions there are, and we will be taking a lot of things on this topic. So, if you're interested in DevOps, then definitely check out our channel. Just type in Great Learning. First, start with Git. Once you're done with Git, go to Docker, and once you're done with Docker, type in Jenkins. Learn about Jenkins, and then type in Kubernetes. So learn all of these four things, and you will have a good start with DevOps. All right. Okay. So let me just finish this off. Now in security groups, I'm going to make sure that we have all the security groups, all traffic. Okay, so Om is saying, I am in 10th class. What is the best course for me? So that really depends, Om. If you want to learn specific something, if you want to get into coding, we have courses on coding also. And again, remember, these are free, so you don't have to worry about anything. Okay, just scroll down, go to IT and software. You'll find a lot of courses over here, like Java programming, introduction to information security, data structures algorithm. So I would recommend starting with Java programming, or starting with JavaScript. So you can start with introduction to full stack development. So that's where JavaScript is there, right? Or you can go with front end development. That is easy and good for beginners. Learn HTML and CSS, and data structures in C is also good. Yeah. So just see what you like and do what you want to do. Okay. If you don't want to go into coding, there's a lot of other domains also, like marketing and digital marketing, and in designing also. If you want to be a designer, that's also there. Hey, no problem, Samath. I just want to help you guys out. Yeah. All right. So, guys, what we're doing over here is basically we'll be launching two. And my phone hotspot immediately, drained my data for some reason. I'm using my mom's phone's hotspot. So let's see. All right. Sorry, guys. Yeah, sorry for the disturbance. Let's get started again. Let me open this up. So first, we're gonna name these Cube Manager, and I'm gonna name this. I don't think we will be able to complete in time because of this today. Cube. Let's call this slave. Yeah. So this can be master manager, whatever. That's fine. So first, I'm gonna take this one, and I'm going to SSH into it. So we'll be using an Ubuntu instance for this purpose. All right. So, Mayank, we have not set up anything yet because of the internet problem. But here's what I'll summarize it for you guys. First, what you need to do is you need to set up your GitHub repository. And once you set up your GitHub repository, you need to push some code to it. Now, once you've pushed some code to it, we will write some configurations, .yaml configurations. First, we'll be doing a service. No, first, we'll be doing a deployment.yaml. And second, we'll be doing a service.yaml. So you guys can see those YAML files over here. This will basically allow us to launch our application. And once we once we are done that, we're gonna go ahead and deploy it using Jenkins. Now I don't think we have time enough to deploy it in Jenkins, but here's what I'll just show you guys the process of installing all of those at least, so that we can at least do it in another session. Continue all of this in another session, right? So first, I'm going to show you guys how you can install Jenkins. Now, first, once you launched your server, you need to update it. Sudo apt update. So we're done updating it. Now we're going to go ahead and install Java. Now Java is a requirement for Jenkins. So you need to install Java. So this is the command: sudo apt install openjdk 8-jdk. So if you guys want this command, just type in how to install Java on Ubuntu. All right. Now I added that -y because it asked me, do I want to continue or not? And I don't like typing yes every time, so I put that -y over there. Okay. So now this is installing Java for basically the Open Java Development Kit. So we'll be using that to launch our Jenkins. I can show you guys till then. What I'll do is I'll go ahead. We'll make a directory. All right. Okay. Yeah. All right. So actually, I should have set it up a little earlier. Okay, now we install Java over here. Now I'm gonna go ahead and install Jenkins properly. Let's just first check if Java is installed properly or not. Yes. Okay. We do one hyphen. Yeah. And let me go ahead and install Jenkins. For that, first we need the sign key. So let me get that key. We got that key. Now we will add the Jenkins repository to our apt package manager, so that we don't get any issues. Now I'll update it again. We should see Jenkins. Yes, .io is one of the packages that we can install. So now we'll install Jenkins. So Jenkins installation is complete. Jenkins installation is this much only. If you guys want to go in more depth where I explain everything, go ahead and check out our Jenkins session video. Okay, the moderator will link it in the chat. All right. So till that is happening, I'll just create my new kube deploy. Yeah, we'll make it public. I'll create the repository. All right, so this is done. So we have installed Jenkins. So what I'm going to do is I'm going to open Jenkins over here. And copy this, come over here, git remote add origin, right, git push origin master. So what I'm doing here is I'm basically pushing the code. Again, if you guys want to know more about Git, check out my Git session. I go into a lot more detail about this. So if you come back, refresh, we should see our code. And to install Jenkins, the whole process is there. You need to get the initial password. To get the initial password, just copy this, come back here, do a cat command. Actually, now we'll do the cat command. This is the first key that we need. We'll paste the administrator initial password. I'll continue. Yeah, hi Atif. Yeah, I see the. Yeah, I'm sorry about the internet connection. Actually, since a lot of us are working from home, we don't exactly have the best internet connection. All right, so this will start working, and we have the hello.html file over here. Great. So now the next thing I'm going to do is I'm going to just take these .yaml files. I'll come over here. Yeah. So over here, I'm going to add more files. Let's say we're going to call this deployment.yaml. I'm going to paste this. All right, let's save it. Now I'm going to create a service.yaml. I'm going to go ahead and paste this. All right, so let me go ahead and stage these. Sorry guys if I'm going a little too fast. I just want to show you guys, I want to show you guys the output, the main part. This is all easy. Doesn't take a lot of effort. Again, if you guys want to know more about Git or Docker, we have specific videos for them. So you guys can see our YAML files are here and HTML file is here. Let me go ahead and finish. Remy, I'll put admin as a password. No need to give my proper email ID right now. I'll just save and continue. And this is the address. Now Jenkins generally starts at 8080, so we don't have a problem. So I'll click on save and finish. Start using Jenkins. Hooray! So finally we've done something in our session, right? I hope that is a milestone where we installed Jenkins. So welcome to Jenkins message is a good thing to look at right now. Fine. So Jenkins is working. That's good. We can go ahead and create a job. But before we go ahead and create a job, we need to set up a Kubernetes cluster. So now I will take time to set up the Kubernetes cluster. So what I'll do is let me just open the steps because I don't have them by hearted. But our first step is to install Docker, right? So first, what you need to do to install Kubernetes is to set up your Docker. Oh no, oh no, oh no, no, no. Yes, yes, yes. Okay, no problem. Yes, not a problem. I thought I had not launched a proper instance, as in the one that is, this instance has at least 8 GBs of RAM and 2 CPU cores, so that is not a problem. Oh, right, right. Atif, don't worry, I'll explain what YAML files are for. So first, let me set up the Kubernetes cluster. So what I'm doing right now is I'm setting up Kubernetes. We have done Git, we have done Jenkins, and now we're setting up Kubernetes. So to set up Kubernetes, you need to install Docker. So we have Docker installed in our first server. So we can see yes, Docker is installed. Now our next step should be to enable Docker. No need to start Docker. I think it should be enable Docker. Let me go ahead and enable Docker, which basically means that Docker starts every time this instance starts, right? Now I'm gonna install some packages that are required for Kubernetes, like your apt transport package and the curl package. Now curl package is generally there, so I don't think there's a need to install curl with Ubuntu. Yeah, so great. So we installed those early packages. Now the next thing we need to do is we need to get the key for Kubernetes. So let me get the key for Kubernetes. So this is the command. We're curling this particular key from over this location, apt-key.gpg. Let me press enter, and we'll add the key to apt, right? And now once we've added the key, we can go ahead and add the repository. So this is how we'll add the repository. This is the command sudo apt add repository and the location of the repo. And once we add that repository, you guys can see packages.cloud.google.com. And next step is basically installing Kubernetes properly. So there's a lot of pre-steps over here. First, we need to install Docker. Then we need to install the apt transport HTTPS package. And then we needed to tell Ubuntu from where to download Kubernetes from. So for that, we needed the key first, and then we told the location. This is the location where we'll be downloading all the stuff from. And now we are installing it or downloading. So this is the command for that, sudo apt get install kubeadmin and kubelet. So you'll be using kubeadmin to initialize a cluster. You can use a lot of different ways. You can use minikube, you can use kops from AWS, or you can use the Google's whatever is there, right? And we're downloading kubelet and kubectl. Kubectl is the main thing over here. There's going to be a CLI, the main command line interface, with which you type in all the commands. So we have all the commands over here. So let me open my slave, because even in your slave, you need to install Kubernetes. So this I won't explain. I'll just directly do it. Let me color this differently so you guys have a distinction. Now, why do I have a slave? So generally in a Kubernetes cluster, you have one administrator and you have one slave, right? The administrator is the one responsible for doing all the managing, and the slave is basically the worker node that does all the work and everything. So sudo su, all right. Okay, so now here what we're going to do is same steps. In first update, then install Docker. Actually, this will take a long... Okay, here's what I can do. I'll install Docker. Let's actually create a shell file, shell script. Nano install.sh. So what I'm doing over here is I'm basically going to take all of these commands and I'm going to paste them here. Instead of typing them one by one, we can just type them, together. So shell scripts basically allow you to execute multiple Linux commands at the same time. Okay. I should have thought of this earlier. Since we are on time crunch, let me press enter. I can come out. You can execute it in two ways: /install.sh. Okay, so let's do sh install.sh instead. All right, so it will start executing all the commands on the go. Oh, Mayank, thanks for coming in and telling us about telling Atif about what a YAML file is. Yeah, that's what I like from you guys. I really like this, that you guys are forming a community by talking to each other. That is important. Talk to each other, help each other out. That is very important. All right. So here we have Kubernetes installed. Now I'll just check if it's installed or not. Kubeadmin, not in it. It is version. Yes, version. Yes, so if you're getting this output, that means your kubeadmin has been installed properly. All right. So basically you have Kubernetes installed, but our cluster is not initialized yet. So we'll just have a second target ready. And once the second slave is ready, I'll initialize the cluster. Now that we have Kubernetes on both the things, first we will initiate our cluster. Kubeadmin init. So generally, you just type in kubeadmin init and we'll start creating initializing a cluster for you. But we need to add one more certain thing. We need to add the pod networking location, right? So I mention that and press enter. So right now it's doing all the pre-flight checks and checking all the things. Remember, Kubernetes requires a lot of resources, so you need a good enough powerhouse of a computer to run, or at least have 8 GBs of RAM. Okay, so if you have Ubuntu in your system, it will be much better for you. So since till it's initializing the cluster, I'll tell you guys what YAML file is. So Kubernetes, again, I told you guys, is an orchestration tool. It allows us to manage multiple containers, right? Now, to create your containers, you don't need Docker CLI for that. You can create something called .yaml files. So let me explain those YAML files to you guys now. So first we have the deployment.yaml. Let me just take this, copy it, put in a new this thing. All right. So over here, yeah, so here this is a YAML file. So YAML file is basically a configuration file where you tell Kubernetes certain things. So if you have a deployment.yaml file, you're basically telling Kubernetes, I want these specifications in my containers. So first you use the API version. So this is important because you need there are certain APIs in Kubernetes that allow you to perform different tasks, right? So we want to perform a deployment. So we need to mention certain API for that. Then you need to mention metadata name of the deployment you're doing, then the specifications of the deployment. Now, in the specifications, you mention the match labels. So your app name is going to be Nginx since you're launching an Nginx container. So I've mentioned that. And next thing we are mentioning is over here is replicas. Now, again, I told you guys what replicas are. They're basically copies of certain things. So if I say two replicas, it will launch an Nginx container, but it's going to launch two of those that are going to be exactly the same replicas of each other, you might say, right? And then we're going to mention the template, and then here we're going to mention the specifications for that template. So template is basically your container template, right? So labels, again, we're mentioning app as the label for that. And containers, you can see we are mentioning the name of the container and the image we're going to be using. So here, this is the image that we're using. So what it will do is, what Kubernetes will do is, it will make use of Docker, and once it talks to Docker, Docker will help it get the image that it wants. So it will go to Docker Hub. Yeah, so it will go to Docker Hub and it will grab the Nginx image that it requires, and it will get it. Okay, so visibility is low. Let me increase that. Yeah. So it will grab the Nginx image and it will pull it and make it into a container. And we will expose the container at the port 80. So the container will be exposed at the port 80. So this is what the YAML file will do. So this is basically used to create our pods. If you guys remember, let me show you that diagram again. So here you see the pods, right? So these are the pods. To create one pod, we need a specific YAML file. So we're telling it. So this pod 1 can have multiple replicas. So pod 1A and pod 1B. That's what we're doing over here. And we're mentioning the image that is to be used for it. We're using Nginx image. And we're exposing at the port 80. Right? So now let's see. Okay, the cluster has been initialized after we did that command. It generally takes a few minutes, maybe 2 to 3 minutes or 4 minutes. And in the end, it will give you a certain command. So kubeadmin join and the token. So you need to copy this token over here. Once you copied the token, you can go to your slave, and in your slave, you can paste the token. Once you paste the token, press enter, and it should have joined. All right, so we need to install Docker here also. Okay, Paplu, you are requesting a session of OpenShift. All right, that is in a recommendation, in a suggestions list. We'll definitely try to get to it. Right, so Docker's installed. Let me try that command again. It's running the pre-flight checks. All right, so this means that the node has joined in the cluster, right? So one of our nodes has joined our cluster. So we can check with the kubectl command, kubectl get nodes. Right, so it will give us this issue. Now what we need to do is basically we need to use this command. So this command basically gives it the Here's what, this command is not generally available. So pause the screen and just type this command out, okay? When it's uploaded as a video later. Okay, now let's try that. kubectl get pods. No resources found. Okay, fine. That means we just don't have any pods right now. That's all right. Let me go ahead and get kubectl get nodes. At least you will see how many nodes we have. So we have 2 nodes right now. They're not ready. So let's make them ready. We'll apply this particular network from kubectl. So it will apply a networking manifesto that will allow us to run these. All right, so let's check that out again. kubectl get nodes. So one of them is ready. Okay, both of the nodes are now ready. They're connected and they're ready. One of the master and the other one we didn't mention the role, we should have, but it is a slave, which is generally what we assume. Okay, so we have both of the nodes. Now if I do a kubectl get pods, you will see that there are no pods. Now if I do all name spaces, all right, so we have certain services running, so no problem. All right, so now what we're going to do is, now just to test it out, we don't have enough time to connect it to Jenkins. We already crossed our 1 hour limit. So quickly, I'm just going to show you guys how you can, basically deploy your YAML files. So let me just go ahead and copy the YAML files I have. So I'll copy this. I'll come back here. I'll do a nano deployment dot YAML. Okay, I'm going to paste this. Let's go ahead and deploy it. So kubectl create -f and you mention the name of the YAML file. So this is the name of the YAML file. Mike is asking kubeadmin init. Are you asking what it is, or if we did it or not? We did do it. We're basically initializing a cluster with that, Mike. Okay, you're saying you got it. Nice. So here we're basically creating a deployment, right? So this is the deployment. We gave the name of the deployment. The name of the deployment is basically Nginx deployment. Okay, so this way we are creating pods. We'll be creating 2 pods over here. So let's press enter. So the deployment was created. So the first thing we will do it, we will go ahead and get the pods. kubectl get pods. So we have 2 pods and they are running. That means our Nginx containers are running. Yeah. Okay, so these things are running. That's really good for us, but we will not be able to access them at all because they're internally exposed, not externally. Now let's just do a quick check and we'll end the session because I need to be somewhere else also. So you can use the docker ps commands and you can see there are a lot of containers running. So docker ps command basically allows you to run the containers, see all the running containers. So let's go ahead and do docker ps pipe grep and I'll type in nginx. Yeah, so grep command basically gets all the containers that have nginx in the name. You can see nginx is highlighted. So we have the nginx containers running on the pod, running on our slave. It's not going to be running on a master. If I do a docker ps, we have some stuff running, but we will not have any of the nginx running stuff running over here. Yeah, so it's not running. It didn't give us anything. All right, so that's your internal deployment where you just have the pods deployed. You don't have a service at all to connect all of these pods. Even if you have 2 pods, you want to connect them with a service, right? So now let me go ahead and put the service in. So the service, same thing is happening. So first we need to go ahead and create the YAML file. I will say service.yaml and I'm gonna paste it, and we need to mention the namespace. So namespace is nginx. Let me go ahead and create that. First I will use the command kubectl create namespace and we're gonna give the name nginx. All right, so let's just see if it's created or not. Yes, so we have nginx namespace created. Now we can go ahead and deploy our service.yaml file. So let me explain the service.yaml file. So basically we have a service. So this is going to be our service, and we have mentioned the metadata, the name of it, the namespace, and the labels it needs to that it needs to, it has, and the specifications we're mentioning. We're using a node port, so there are a lot of different types of services. So this is the kind of service, but there are a lot of different types of services, right? So we're using node port for our service, and let me change this to 80. So node port is available at port and node port. Okay, so this is basically port exposing it at the exposing the host. All right, so let me just copy this instead. Nano service.yaml. Let me remove all of this, paste this. All right, so now I'm going to go ahead and deploy this. So kubectl create -f service.yaml. Okay, so it gave us an error. Let me check what the error was. It should work. It just made it work. I must have missed out something in all the hurry. Anyways, guys, so service is showing some error. We do not have the time to resolve it right now. So here's what I'll just do: a small AMA and let's get it done. All right. So if you guys have any questions, go ahead and ask me. I'll answer them from 2-3 minutes. So there is a power outage. I think my laptop is also gonna die anytime soon. So let's go ahead and do a AMA. So Mayank is asking, can we configure it using kind, sir? Yes, we can, Mayank. All right, so while you guys are asking questions, let me just tell you how you would do it. Let me open. So we're basically using GitHub to, store all the configurations, like all the YAML files, the code, and everything. We're using Jenkins to do all the automation where we create the pipeline and everything. That will basically have the steps. It will have the steps for deploying. So if you want to deploy, Jenkins is the one that is going to be deploying. Now, Kubernetes is basically our infrastructure. It's our infrastructure where we are deploying. Okay, so we have a local cluster that we created ourselves that has not been exposed anywhere, right? And it will be infrastructure. It manages all the containers, and Docker is the one that creates the containers. Yeah. So we store all the code and the .yaml files required for Kubernetes in GitHub, and in Jenkins we basically mention the GitHub link, and we basically clone the link, and then we run the Kubernetes commands in the pipeline that will basically execute all these commands only. The service.yaml create the services, create the pods, and once we put those commands in, we'll basically build the Jenkins job that we've created, and we'll configure it in such a way that it automatically gets built whenever we push code to YAML GitHub. So if I suppose push new code by changing the HTML thing with adding more stuff, then it will automatically detect that change happening, and it will go ahead and build our job, Jenkins job. And once it starts building that, it will deploy a new container on the infrastructure, on the cluster, and it should have been available to us by accessing the IP of the slave. So generally, if you put the IP, we should have been able to see at least the Nginx welcome message. Yeah. All right, Mayank, definitely will continue the session later in future. All right, thank you guys so much for watching. I'm really, really sorry for the blackout. I really didn't have it controlled, but try to make sure in future that I have some kind of backup. But I hope you guys really enjoyed this session, like got something out of it. Now I know there's a lot of knowledge just being thrown at you. It's a lot of knowledge being thrown at you, so it's all right. Here are the steps I'm telling you guys again. Just go to Great Learning. First type Great Learning Git, then type Great Learning Jenkins. Then I would recommend Docker, then Kubernetes, then Jenkins. So learn all of these, huh? Just learn Git, Docker, Kubernetes, and Jenkins. and then come back over here. All right, guys, thank you so much for watching. I really again enjoyed teaching you. I hope you guys come up for our more sessions. If you guys want to see which all sessions I'm doing next, just head to greatlearning.in/academy, and we have the upcoming live sessions. If you just scroll down a little bit. And again, for the person who wanted about Angular, you can check out Faizan's session that is on 21st November. You can it's on Saturday, right? And we have a lot more sessions. And if you guys are a fan of Python, we have a Python course on Thursday, 19th November. This is a must. I definitely recommend if you're a beginner, especially for the person who was telling me that they're in 10th. I would recommend you going through these courses. This is a live course. Bernie is an excellent trainer. He will teach you guys about Python from the beginning, all the things that you guys want to know. Okay, so definitely go and try this, attend this session. November 19th, Thursday, 4 to 5 p.m. Okay, guys. So thank you so much for watching. See you guys. My name is Ram, and I'll see you guys in my next.